right. Here we go. I am very tired today, so if I get goofy, you'll have to excuse me, because I get goofy when I'm tired. I've been tired all day. Huh? I know. I don't know why, but I get goofy when I'm tired. All right. You might say you're goofy anyhow. Yeah, well, I know. All right, here we go. Properties of multiplication. So here's what we're going to do today. We're going to really end up very similar to where we were the other day. We're going to deal with a lot of the same properties, only now we're going to be multiplying instead of adding. Now, some might say, what are these properties anyhow? Why do we even need to know? Why do we even need to know them? To be honest with you, 20 years ago, we didn't worry about the properties much. 30 years ago, definitely didn't worry about the properties much. Back when I was in school, way too long ago, we definitely didn't worry about the problems or the properties. But you know what? In reality, the properties do tell you what is allowed within math and what's not allowed. And that's where we're trying to get you guys to go. So the first one is, I think, always the toughest, and it's the closure property. All solutions produce a result that is part of the same number set. And I don't know, box in, circle, number set. I mean, that's the key with closure. In other words, when we're multiplying, we'll end up with the same number set. Now, we could multiply natural numbers. Is the answer always a natural number? We could multiply whole numbers. Is the answer always a whole number? We could multiply integers. Is the answer always an integer? It depends on what number set we want to deal with. So I got a couple examples for you. So we're going to use integers. So here's what closure will say then. No matter what two integers you multiply, we should end up with an integer. If that's the case, it's closed. We have closure. Now, let me also emphasize again. You might be able to find 700,000 things that work. But if you can find just one that does not, then it's not closed. Everything has to work. So you might find 3 examples, they all work, and say, oh yeah, it's closed. Well, maybe you didn't think of the example that doesn't work. So closure, you got to be careful. All right, so 3 times 7 is 21. So here's the question. Is 21 an integer, yes or no? So that one worked. The second example, I tried a negative integer and a positive integer. Is negative 2 times 10, that's a negative 20. Is negative 20 an integer? That one worked. Now I tried 2 negatives. Negative 8 times negative 5 is a positive 40. Is 40 an integer? That one worked. And honestly, I should have done one more example. Let's do a 0 example. How about 0 times negative 7? What's 0 times negative 7? 0. Is 0 an integer? Yes, it is. That one works. So is the operation of multiplication closed for integers? Yes. No matter what integers you try, your answer will always be an integer. So you might say, all right, Mr. Scarfy, you showed me one that works. Show me one that doesn't work. All right. We got a little bit of space right here. Let's just do in here, make a little box here, throw in. How about natural numbers? Oh, wait a minute, that one's going to work. So that's that. No matter what 2 natural numbers, right? 1, 2, 3, and above, we always get a natural number. 1 times 7, 7. 3 times 5, 15, natural number. 37 times 2, 74, natural number. 100 times 100, 10,000, natural number. Yeah, that one's going to work. All right, so that one's closed. How about whole numbers? What's the only difference with whole numbers? You get 0. 0 times 5, is that a whole number? Yeah, you get 0. 0 is a whole number. 2 times 11, 22, is that a whole number? Yeah, that one works. And you could go on. Whole numbers works as well. Integers, we already know works. Rational numbers. Rational times a rational, will that always give you a rational? Rational numbers are fractions. So no matter what fraction times a fraction, do you always get a fraction? Believe it or not, that one works. Most of the normal number operations are closed for multiplication. Irrational numbers, you guys don't know well yet, so we'll leave them off. But as I'm thinking off the top of my head, even those are closed. So most things closed for multiplication. Okay. Here's one I can do this. Here, let's do this. Just thought of one that's not multiplication but will work. Let's do the integers for division. Are the integers closed for division? Meaning, whenever you take an integer and divide it by any other integer, will you always get an integer? So, if you think it's no, can somebody raise their hand and give me an example that doesn't work? Go ahead, Christina. Edward? All right. Is 7 an integer? Yes or no, class?
Yes.
Is 3 an integer? Yes or no?
Yes.
Does it equal an integer?
Yes.
No. 7/3 is not an integer. It's a fraction. It's a rational number. So it's not closed. No, it does not equal an integer. So there's an example of something being not closed under division. We took an integer, we divided it by an integer, and we did not get an integer as an answer. We got a rational number, a fraction. And therefore, it is not closed. Christina. Remember, 6 divided by 3 is 2. That's an integer. You can find a million things that work. But as long as you can find at least one that doesn't work, then it's not closed. It's got to work for every single thing in the world. You can find one example that doesn't work. Nope, not closed. You only need one example against. You can have a million that do work. One that doesn't, it is not closed. All right, number 2. Number 2, the commutative property. C-O-M-M-U-T-A-T-I-V-E. Whoever's the N person, you get rid of that N. Commutative. Well, you might hear me say something that sounds a lot like commutative, but it's commutative. But I will definitely sound a lot like commutative. All right, and everybody now knows that the commutative property tells you can change the... That's got to be in your brain. You got to associate the word order with the word commutative. This time we're multiplying instead of adding. So you can see the variable example here. We have an A times a B. The A is first, the B is second. Take your red, put the B first. Take your blue and put the A second. We change the order. You know when you guys first learned this property? What grade do you do your times tables in? Anybody know? 3rd or 4th? So you were there, whatever grade you were in. Class, we're doing our 2 times tables today. Ooh, class, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And on she goes. And then, I don't know how many days later, because you got to really work on those 2's. Class, today is our 3 times tables. Now, of course, you reviewed all the other ones up to that point. We're going to do our 3 times tables. 3 times 1 is 3. 3 times 2 is 6. And Johnny raises his hand. Miss Oglethorpe? Miss Oglethorpe? I thought 2 times 3 is 6. You're telling us that 3 times 2 is 6. What's up with that, Miss Oglethorpe? All right, he's got an attitude problem, obviously. With an attitude like that, Johnny, you can see me after class and I'll tell you. No, Johnny, that's the commutative property. Now, she's not going to say that then. But that was the commutative property, right? 2 times 3 is the same as 3 times 2. We can change the order. Hey, that's all it is. Not a big deal. Don't let it cause you any consternation. We all know that 3 times 5 is the same as 5 times 3, right? No matter which way you look at it, it's still 15. And you can do it with positive and negative numbers as well. It doesn't matter. You know why? Check this out. A positive times a negative is a positive times a negative is a negative. What's a negative times a positive? See, you can change the order, right? It doesn't even matter if they're both positive, both negative, or one's positive, one negative. So an x times 7 is the same as a 7 times x, right? And by the way, I'll throw this out now. I'll mention to you many more times. The x is a variable. The proper order is to always have the number in front of the variable, not vice versa. Proper notation, write the number first, then the variable. All right, next is the ever popular in green associative property. And this time again, we're going to do with multiplication. The associative, ASSOCIATIVE, and everybody remembers your associates are those that you hang out with. So with the associative property, when multiplying, what can change? The grouping, and you need to make sure that you associate grouping with associative. You can change the grouping. Now, there was one homework problem last night that I thought some of you would raise your hand and say, Mr. Scarfy, why isn't that associative? But nobody asked me the question. Matter of fact, somebody, when we were grading, said, this person has 2 answers. Can it have 2 answers? And I said, no, mark it wrong. And it was probably the one where they wanted to say associative. Well, associative is changing the grouping. In this example, the B and the C are grouped together. Now let's change and group the A and the B. Notice the order has not changed. On the left, there's an A, B, C. That's the order. A, then B, then C. On the right, what's the order? A, then B, then C. Has the order changed? No. But what has changed? The grouping. B dissed C and says, you're out, C. I'm in with A now. Hit the road, Jack. All right, that's it. It's probably a girl property. Because girls have to have their best friend, bestest, best, forever, ever. And guys say, 3 of us cool, 8 of us cool, 20 of us even more cool. We'll all be friends. All right, that's the way it is. So it's a girl property, I guess. All right. Now, associative, and so you just change the grouping. And just a simple example of proving it works for this scenario. Let me get rid of this shade so I can go higher for you. So here, if we use our example, so take your black, make the 4 first, then the 3, then the 2, right? Don't change the order. Take your green and change the grouping. Group 4 and 3 now. So by following the order of operations, let's see if we end up with the same answer. We're supposed to go inside of parentheses first. So the front one ends up being a 4 times 6, right? And the back one ends up being a 12 times 2. And look, lo and behold, 24 equals 24, right? We can change the grouping, and we'll still be good to go. We're still going to have the correct answer. We're allowed to change the grouping when everything's being multiplied. You know, here's a simplistic example to this. I don't think you need to write it, but here's a practical application of this. You know, let's suppose you had something like this. 5 times 7 times 10 times 2. Okay, so you can, that's maybe not the best example. That 10 is too easy. Let's get rid of that 10. Let's go 5 times 7 times 9 times 2. You know, I'd probably want to do 5 times 2 first and get 10. And then I can do 7 times 9 and get 63, and 10 times 63 is 630, and I'm done with the number, right? Instead of just going in the order it was, I changed the order up to be more advantageous to me because I could multiply those a whole lot better in my brain. So that's a practical use of the associative property. All right, let's do the next one. Next is in blue, the identity property. I had the indie-denty. All right. Identity property. Don't trust your spelling to me. Identity, I-D-E-N-T-I-T-Y, the identity property. And we all know that gets you back to the original. Not back to the future. That's coming up real soon. When is that? Like October 8th or something, I think? No, that was like the day in the movie that they, I think, were in initially and went back to. So whatever day, yeah, I think they started in that day and went back or went forward. Who knows? Whichever way they went. All right, so if you look at the example, we have an A, and we need to end up at an A, right? We're back to the original. And we had this with addition. 0 is called the identity element of addition. 1 is the identity element of multiplication. Meaning if you multiply anything by 1, you get back to the original, right? Multiply anything by 1, you're back to the original. The first example is pretty obvious, right? Like second grade. 3 times 1 is 3. But you know what? In our algebra, we're going to use this principle a lot. 7 divided by 7 is? So therefore, the answer has to be? 3x, right? We're back to the original. That's the identity property. Back to the original. Back to the original. And a 3 squared minus 8, well, that's just a 1 as well. So what does this one equal? Negative 5xyz. Look at that. Amazing. You're doing algebra. Right? Because anything times 1 is back to the original. Anything times 1 is itself the original. Any questions on any of that? Anybody? Yes, Emily. All right. Number 5. Cinco, no de Mayo. Number 5. All right, 5 is the inverse property. All right, this one you got to be careful with. When we were adding, the inverse of addition said you could add opposites. But with inverse, you multiply by the reciprocal. So for addition, you're adding opposites. For multiplication, you're multiplying by the reciprocal. Uh-oh. Does anybody remember what the reciprocal is? Brendan? Not quite, no. But at least you're trying. What is the reciprocal? Reciprocal. Emily? Second number? You mean like if the number was 3, the reciprocal is 4? No, but at least you tried. Does anybody really know what the reciprocal is? All right, Christina, give it a shot. Nope. Opposite would be negative 3, but that's not the reciprocal. And if we were adding, to get the inverse, you got to add opposites, but multiplication is different. Kristen? Use 3. What would be the reciprocal of 3? What is the reciprocal of 3? No. Chloe? Nope. 1 is not the reciprocal of 3. Brendan? No. Well, we're narrowing it down. Only got a million other things to go before we find it. Edward, what's the reciprocal? No. All right. I've come to the conclusion you guys have no earthly idea what the reciprocal is. So let me show you what the reciprocal is. Let's do an easier one. Let's do a fraction because fractions are easier. What's the reciprocal of 3/2? Kristen? It is 2/3. Quiet, please. Yeah, the reciprocal is just simply the flip of a number. So let me do one that you wouldn't know as well. Oh, you know what? We'll do it down here. So let's go through and figure out reciprocals. What's on the bottom of a number 3, though we never mention it, though it's down there? What's the bottom of any whole number? What's on the bottom? A what? A 1. So what happens when you flip a 3 over 1? What do you get? A 1 over 3. And 3 times 1 over 3 equals 1. Because whenever you multiply reciprocals, you get 1. What's the reciprocal of -7? It would be 1 over -7. Because it's a -7 over 1, you flip it. Put the 1 on the top, -7 on the bottom. -7 times 1 over -7 is 1. What's the reciprocal of -2thirds? It would be positive 3 over -2, right? And if you multiply that out, you get 1. You get uno, not the game. All right, so hey, reciprocal, guys. So be careful with inverse. It's different for addition and multiplication. However, you do end up at 1 in both cases. With the, no, you end up at 0 and you end up at 1. Take that back. So you add opposites to get 0 in addition. You multiply by the reciprocals to get 1 in multiplication, Chloe. Yes, and we need to finish that. Correct. A times 1 over A equals 1. Thank you. And that is correct. Don't let the letters scare you. It just represents a number. Okay, it's all it is. And again, technically, the A is A over 1. What's the flip? 1 over A, right? Just like numbers. All right, last property of the day. And it's the zero, take your red, product property. What operation gives a product? Somebody raise their hand and tell me what operation gives a product. What operation, Juliana? Multiplication, right? So the operation, that's why the word times is right there, right? We're multiplying. And look, we know the answer to this. Any number times 0 equals 0. The product, the solution, is always going to be 0. Anything times 0 is 0. So to finish this off, 3 times 0 is 0. Oh no, algebra. -n times 0. I'm quaking in my boots. 0. Oh, you guys, too quick. Oh, wait a minute. Here's a hard one. -3ab squared c times 0. All right. Here's a hard one. 3 times -2x times 4y squared times -7 n to the -5th p squared to the 0 times 0. You guys are amazing, right? Math's easy if you know the property. Hey, I don't care if you're multiplying 50,000 things in a row. If one of them is a 0, the product's going to be 0. It's not gum in your mouth, is it? Good. All right. So that's the lesson. Let me recap. So closure. Everybody hold on a second. Just don't do anything. My time, not yours. Stop. Pause. Freeze. Freeze. Omar, do you know what freeze means? Do you know what freeze means? Freeze. All right, so let me review. Remember, closure. Whatever number set you begin with, if you perform the operation, you end up in the same number set. That's closure. If you can find one time where it doesn't work, it is not closed. Commutative, keyword, order. Keep those two together. You can change the order, it's commutative, whether you're adding or multiplying. Associative, keyword, grouping. You can change the grouping, and it's associative. Identity, back to the original. Inverse, be careful. you're multiplying by the reciprocal, you'll always get 1, and then 0 product. Anything times 0 is 0. All right, you guys got your homework at the bottom of the page, and you got a few minutes left of class.